Cool. So let's take a look at the documentation for a switch statement. And I like doing this in my classes at the college and the university. I like just to sometimes sit back and have story time where we get out a nice book like the Go language specification and do a little reading together. And I like that because I think it's really important as a programmer, as a developer, to be comfortable with the docs, to know what the language spec is, the language specification, to know what effective Go is, to be able to go and make sense of the way that the people wrote these documents, the way they wrote them. And so it's a skill in and of itself, and you have to understand the terminology. And by reading through these together, I could explain things where students sometimes get confused or explain concepts or words or ideas. And it's just familiarizing that skill and making the docs not something scary, but something which is your friend and a resource to be called upon. So if you feel comfortable with all that, by all means, jump ahead from here and go to the next video. But if you'd like to hang out and look through the docs with me, you're in the right place. All right. So now let's take a look at the key words. So the first thing is just look at the key words that we've already learned. We saw when we were looking at our loops, right? We saw case, which goes with switch and fall through. And just a little quiz question for you here. So when you're going to do a switch, do you do switch and then have cases, or do you do case and then have switches? It's switch, right? And then you have cases. So that's it. So we've seen break, case, switch, fall through. We've seen continue. Yes, we saw continue. And let's see, we saw else, and we saw for, and we saw if, and we saw, I have to remember what I've taught here and what I've taught elsewhere. We saw switch, we saw that one already, and we saw var. So we've knocked out quite a bit of these, and that's pretty cool. And if we go up just to pat ourselves on the back, and just for me to commend you, and for us to measure our progress and see how well we're doing, we've seen Boolean types and numeric types and string types, and we've also seen if statements and switch statements and for statements and assignments, right? So we've seen some good stuff. We've seen break statements and continue statements. We're starting to knock out some of this language specification and understand, oh, here's this whole document, 50, 60 pages, how the Go programming language works, and we've done a fair amount of it already. So that's good. We're doing great. But now let's take a look at the documentation for a switch statement. So I'm going to come down here. Switch statements provide multiple way execution. Let me bring this down. There we go. Switch statements provide multiple way execution. An expression of type specifiers compared to the cases inside the switch to determine which branch to execute. There are two forms, expression switches and type switches. We've only looked at expression switches. In an expression switch, the cases contain expressions that are compared against the value of the switch expression. The value of the switch expression. So the cases contain expressions, right, that are compared against the value of the switch expression. That's so important. I'm going to super simple highlight that into orange. In a type switch, the cases contain types that are compared against the type of a specially annotated switch expression. The switch expression is evaluated exactly once in a switch statement. So let's look at expression switches. In an expression switch, the switch expression is evaluated, and the case expressions, which need not be constants, are evaluated left to right and top to bottom. The first one, so cool words here, switch expression is evaluated, so the switch expression is evaluated, and the case expression is evaluated, right? And are evaluated left to right, top, and the first one that equals the switch expression, triggers execution of the statements of the associated case. The other cases are skipped. We will green that one. Cool. If no case matches and there is a default case, its statements are executed. We'll make that one orange. There can be at most one default case, and it may appear anywhere in the switch statement. Interesting. What color should we give that? It's kind of an interesting thing. We'll make it a yellow. A missing expression is equivalent to the Boolean value true. So a missing expression, a missing switch expression is equivalent to the Boolean value of true. So that's why we are able to do, just so you could see how that works, that's why we're able to do this one. And let me make sure that I got that code copied. Do we have this one, this last one? It ends in, and I'm going to come over here and bring that down to, cool, we got it. All right, so that's why we could do a switch statement like this, and we'll just kind of get rid of all that so you can see me code this out. Switch, right? So missing, and let's just look at the wording on that. A missing switch expression, so that's the switch expression. The switch expression is equivalent to the Boolean value true. So if we have nothing here, it's like the value true is there. And so what that's going to look for is a case which is also true. So missing switch expression defaults to true. That's cool. And then here we have some EB and F, right, where we have the switch. And is that a keyword? Is that a keyword? That's a keyword. We just saw that. We have the switch and then optional stuff because of brackets, right, optional stuff. And then we have curly braces. And then we have expression case clause. And an expression case clause is equivalent to expression case clause colon statement list, and or expression switch case colon statement list. And expression switch case has the word case, and then expression list or default, right? And then the default keyword. So that's pretty cool. That pretty much tells us that syntax, how we write those. If the switch expression evaluates to an untyped constant, it is first converted. So we get into a little bit more detail here. Let's look at effective go and see what effective go says. Nothing that I've highlighted here. A switch can also be used to discover the dynamic. That's a type switch. Oh, here we go. There's a little bit of highlighting. Switch. Go switch is more general than C's. Expressions need not be constants or even integers. The cases are evaluated top to bottom until a match is found. And if the switch has no expression, it switches on true. So the switch has no expression. If the switch has no expression, the switch has no expression. We'll make that orange. We saw that over in the language specification. It's therefore possible in idiomatic to write an if-else chain as a switch. So switch, and then we're just looking for something that evaluates to true, right? We have some logic here. The ampersand means, hey, is this true? And is this true? Right? And these are bringing things over from a channel. So we'll learn about that a little bit further. Cases can be presented in a comma-separated list. So here are a couple of different cases. Empty, a question mark, an ampersand, an equal sign, right? If any of those are what is this, then we're going to return true. So that's a little bit of reading the documentation. Just wanted to make sure that you're getting some exposure to that and that you are familiar with it and that you use it as a resource as you're writing your Go code.